Before we talk about what happened, I want you to picture something with me. It is a warm evening, 12,800 years ago. The place that will one day be called Syria does not have that name yet. It does not have any name, really, except the ones whispered by the small groups of people who move through this land with the seasons. Living as humans have lived for hundreds of thousands of years. A family sits outside their shelter. It is made of branches and hides, temporary but sturdy. A woman tends a fire. Her daughter, maybe 7 years old, practices working a piece of flint, trying to copy the way her mother's hands move. An older man, perhaps the girl's grandfather, tells a story the family has heard many times before. It is about the stars, about animals, about the spirits that live in the world around them. The fire crackles. The night is clear. Above them, the sky is more filled with stars than you or I will ever see in our lifetimes, because there are no cities, no lights, nothing between them and the endless depth of space. And then something changes. At first, it is just a brightness on the horizon. The storyteller stops mid-sentence. They all turn to look. The brightness grows. It spreads across the sky like dawn arriving from the wrong direction. But it is not dawn. It is still the middle of the night. The girl asks her mother what it is. Her mother does not answer. She does not know. Within hours, their world will be unrecognizable. Within days, nearly everything they know will be gone. The herds they follow, the plants they gather, the very landscape itself. All of it will be transformed by forces so violent that we, 12,800 years later, are still finding the evidence burned into the rocks. But right now, in this moment, they just watch the sky growing brighter and brighter. And they do not yet understand that they are witnessing the beginning of the end. Now, flash forward to 1999. A geologist named Richard Firestone is examining soil samples from sites across North America. He is looking at layers of earth that date back to the end of the last ice age, right around 12,800 years ago. And he keeps finding something strange. There is a layer, thin as a pencil line in some places, that appears again and again. It is black, charred, dense with particles that should not be there. Under the microscope, he finds nanodiamonds, tiny crystalline structures that only form under extraordinary heat and pressure. He finds platinum at concentrations 100 times higher than normal. He finds spherules, tiny beads of rock that have been melted and resolidified. He finds the fingerprints of catastrophe. And here is the thing that makes it truly eerie. This layer is not just in one place. It is not just in North America. Scientists eventually find it in Europe, in South America, in Asia, across 4 continents, at exactly the same point in time. There is this black mat of destruction, this scar in the earth that tells a story most of us never learned in school. Something happened 12,800 years ago that changed everything. The temperature of the Northern Hemisphere dropped 15 degrees Fahrenheit in less than a decade. 15 degrees. Not over centuries. Not even over a generation. Within the lifetime of a single person, the world went from warming, from thawing, from slowly emerging out of the Ice Age, to plunging back into a deep freeze that would last more than 1,000 years. 80% of the large mammals in North America went extinct. Woolly mammoths, mastodons, giant ground sloths the size of elephants, saber-toothed cats, dire wolves, animals that had survived hundreds of thousands of years of climate change. They all vanished within a geological eye blink. And the strangest part? Some of them died so quickly that their bodies tell impossible stories. Mastodon tusks have growth rings, like trees. Scientists can read these rings to understand what the animal experienced during its life. And in some of these tusks, the rings just stop. Not at the end of a season, not during a harsh winter. They stop in the middle, mid-growth, as if the animal was thriving one week and gone the next. Trees that were healthy and strong suddenly died standing up. Their remains show no signs of disease, no gradual decline. They were alive, and then they were not. What could kill a continent in days? For a long time, nobody knew. The Younger Dryas period, as it came to be called, was a mystery. Climate scientists knew it happened, They could see it in ice cores from Greenland, in sediment layers from lake beds. In the fossil record, the Earth had been warming, the ice sheets had been retreating, and then suddenly, violently, the Ice Age came roaring back for 1,200 more years. But why? What could cause such a dramatic, instantaneous shift? Some scientists suggested it was a shutdown of ocean currents. Others thought maybe volcanic eruptions. But none of these explanations quite fit the evidence. Ocean currents do not leave nanodiamonds in the soil. Volcanoes do not create platinum spikes across 4 continents simultaneously. It was not until the early 2000s that a small group of researchers started putting together a different picture. A picture that sounded, frankly, like science fiction. They proposed that Earth was hit by fragments of a comet, not one impact, multiple impacts. A comet breaking apart in the atmosphere, raining down destruction across the northern hemisphere. Airbursts powerful enough to flatten forests, impacts large enough to punch through ice sheets 2 miles thick, firestorms that consumed 10% of the planet's biomass in a matter of days. And the evidence, once you know what to look for, is everywhere. In 2018, scientists discovered a crater in Greenland, buried beneath ice. It is 19 miles wide. They named it Hiawatha. Dating suggests it formed right around 12,800 years ago, 19 miles wide, from a fragment of something that came from the cold depths of space and slammed into our planet at tens of thousands of miles per hour. Imagine standing on the ice sheet that day, far enough away to survive, but close enough to see. The sky splits open. There is light brighter than 1,000 suns. The air itself ignites. The shockwave levels everything for hundreds of miles. Chunks of ice the size of mountains are thrown into the atmosphere. And then, in the weeks and months that follow, all that debris, all that dust and ash and vaporized rock, it spreads across the sky, blocking out the sun, turning day into twilight, sending temperatures plummeting. This is not ancient mythology. This is physics. This is geology. This is what the evidence shows happened to our planet just 12,800 years ago. And somehow, against all odds, humans survived. Your ancestors survived. Every single person alive today descends from the people who lived through that, who watched their world burn and freeze, who lost nearly everything and kept going anyway, who found a way to endure through the longest, darkest, coldest years in human history. That is what this story is about. Not just the catastrophe, not just the science, but what it means that we are here at all. My name is Mr. H, and if you are listening to this to fall asleep, that is perfect. That is exactly why I make these. So go ahead and get comfortable. Maybe lower your screen brightness. Let your eyes close if they want to. You do not need to remember any of this. You just get to rest while I tell you the story of the day the world almost ended, and what the people who survived it can teach us about resilience, about hope, and about the stubborn refusal of life to let the story end. And if you are still awake enough, drop a comment and tell me where you are right now and what time it is. I love knowing this is becoming a little ritual for people all over the world, all of us settling in at different hours, different time zones, but all looking for the same thing. A story, a little peace, maybe some wonder before we sleep. All right, let us go back to a world that does not exist anymore, back to the late Pleistocene, when North America was a place so different from today that it might as well have been another planet. The world that existed 12,800 years ago was not the world you learned about in school. When most of us think about the Ice Age, we picture a barren wasteland, endless white, everything frozen, a few shaggy mammoths wandering through the snow, maybe some primitive humans huddled in caves, barely surviving. But that is not what it was like at all. Yes, there was ice. Massive ice sheets, miles thick, covering Canada and parts of the northern United States. But south of that ice, across most of North America, the landscape was thriving. It was lush. It was alive in ways that would astonish you if you could see it. Picture this instead: grasslands stretching to the horizon, richer and more diverse than the prairies we have today. Forests of spruce and pine mixed with deciduous trees we would recognize, oak and willow and birch. Rivers and streams everywhere, fed by the melting edges of glaciers to the north, creating wetlands and marshes that supported an explosion of life. And in these grasslands, these forests, these wetlands, there were animals. Not just animals, megafauna. Creatures so large, so strange, that if you saw them today, you would think you were hallucinating. Woolly mammoths, of course, but also Columbian mammoths, a different species, even larger. They stood 13 feet tall at the shoulder and weighed up to 10 tons. 10 tons! That is twice the size of a modern African elephant. Imagine looking up at something that massive, watching it move through the grassland, its tusks 16 feet long, curving and crossing in front of it like enormous ivory scythes. There were mastodons, shorter and stockier than mammoths, with straighter tusks, living in the forests, browsing on leaves and branches. There were giant ground sloths, some species as big as elephants, walking on their hind legs, using their powerful claws to pull down entire trees to get at the leaves. There were saber-toothed cats. Not just one kind, several species, each specialized for different prey. Smilodon fatalis, the most famous, with canine teeth 7 inches long, designed to deliver a killing bite to the throat of animals much larger than itself. There were dire wolves, bigger and more powerfully built than modern wolves, hunting in packs. There were American lions, 25% larger than African lions today, the biggest cats to ever walk the earth. There were giant, short-faced bears, standing over 6 feet tall at the shoulder, when on all fours, 11 feet tall when rearing up, weighing over a ton, possibly the largest carnivorous land mammal that ever lived. There were giant beavers the size of modern black bears. There were armadillo-like creatures called glyptodonts, with shells 10 feet long. North America was where camels evolved, and there were multiple species still living here, including one called the western camel that stood 7 feet tall. There were horses, small ones, stocky ones, adapted to the grasslands, the ancestors of the horses that would eventually cross into Asia and become the horses we know today. And there were tapirs and peccaries and giant tortoises and teratawns, massive birds with wingspans of 12 feet, soaring over the landscape looking for carrion. This was not a dying world. This was not a world waiting for the end. This was a world at its peak, and moving through this world, hunting these animals, living alongside them, adapting to them, were people. The Clovis people, we call them now, after the town in New Mexico where their distinctive spear points were first discovered. They had their own names, their own languages, their own stories about who they were and where they came from. What we know is this: they were sophisticated, they were skilled, they were successful in ways that required intelligence, cooperation, and deep knowledge of their environment. Clovis points have been found at over 9,000 sites across North America. 9,000. From Alaska to Mexico, from the Pacific coast to the Atlantic. These were not isolated bands barely eking out survival. This was a widespread culture with shared technology, shared methods, shared knowledge that spanned a continent. And their technology was remarkable. A Clovis point is not just a sharpened rock, it is a work of art and engineering. These points were made from high-quality stone, often sourced from quarries hundreds of miles away, which tells us they either travelled great distances or had trade networks that moved materials across regions. The points themselves are flaked on both sides, thinned in the centre, with a distinctive flute, a channel running partway up from the base that makes them easier to attach to wooden shafts. Making one of these points requires knowledge of stone properties, incredible hand-eye coordination, and hours of careful work. You have to understand how the stone will fracture, where to strike, how hard, at what angle. One mistake and the whole thing shatters. Archaeologists today, people who have spent years studying this, still struggle to replicate Clovis points with the same precision and quality. These were master craftspeople, and they were teaching this skill to their children, passing down knowledge generation after generation. At some sites, archaeologists have found what appear to be practice pieces, smaller points made with less skill, suggesting young people learning the craft, guided by adults who already mastered it. Think about what that means. A mother sitting with her daughter, just like the family we imagined earlier, showing her how to hold the stone, how to position the antler tine she uses as a hammer, where to strike. The girl's hands are small and clumsy at first. The stone breaks wrong. The mother smiles, hands her another piece, shows her again. Patient, encouraging. This is happening everywhere. In countless families across the continent, knowledge flowing like water from one generation to the next. They were not just surviving, they were thriving. The archaeological evidence shows us that Clovis people hunted mammoths and mastodons. We have found mammoth bones with Clovis points embedded in them, kill sites where these massive animals were brought down, butchered, their meat and hides and bones used for food, clothing, tools, shelter. Bringing down a 10-ton mammoth with stone-tipped spears is not something you do alone. It requires planning, coordination, multiple hunters working together, understanding the animal's behavior, knowing where to strike, when to fall back, how to finish the kill without getting trampled or gored. It requires communication, language, complex enough to plan, to adjust strategy in real time, to teach the next generation not just what to do but why. And it requires courage, facing down an animal that could kill you with one swipe of its trunk, trusting the people beside you to do their part, knowing that if this works, your family eats for weeks. But they did not just hunt. They gathered. They fished. They understood their environment in ways we have lost. They knew which plants were edible and when they ripened. They knew which roots could be dug up and stored for winter. They knew where the fish ran, where the bird migrations passed through, where certain animals would be at certain times of year. They made tools from bone and antler. They sewed clothing from hides using bone needles and sinew thread. They made shelters, some temporary, some more permanent, designed to withstand the weather and keep families safe. At some sites, archaeologists have found evidence of artistic expression. Carved bone, decorated tools, ochre, a red pigment processed and presumably used for body paint or decoration of objects or possibly ritual purposes. These were people with inner lives, with creativity, with a sense of beauty and meaning beyond just survival. They told stories. We know this because every human culture tells stories. It is one of the things that makes us human. Around their fires at night, they told stories about the animals they hunted, about the land they lived on. They told stories about their ancestors, about great hunts, about times of plenty and times of hardship. They laughed, they sang, they held their children and felt the same fierce protective love that parents feel today. They looked up at the stars, the same stars we see, and wondered what they were. They watched the moon go through its phases and learned to track time by it. They noticed patterns in nature and built their lives around those patterns. And they had been doing this, not for a few generations, but for thousands of years. Humans had been in North America for at least 15,000 years by this point, possibly much longer. The Clovis culture itself emerged around 13,000 years ago and had been flourishing for 200 years when the impact happened. 200 years. That is 8 or 9 generations. Great-great-great-great-great-great-grandparents, passing knowledge to great-great-great-great-great-great-grandchildren. Stories getting richer, skills getting refined, trade networks expanding, population growing. By 12,800 years ago, it is estimated there were hundreds of thousands of people living across North and South America. Maybe more. We will never know the exact number because so much evidence has been lost. We know they were spreading, adapting to different environments. The world was warming. The ice sheets were retreating. Climate data from ice cores and sediment layers shows that the period right before the younger Dryas impact was actually one of increasing warmth and stability. The future looked bright. If you could have asked someone living then what they thought would happen next, they might have told you about the good hunting grounds opening up to the north as the ice melted. They might have talked about their children, about passing on the knowledge they had learned. They might have looked forward to the next gathering with neighboring groups, the next trade, the next shared feast. They had no reason to think their world was about to end. None of us ever do. That is the hardest part to wrap your mind around. These were not people living on borrowed time. They were not primitive or fragile. They were competent, knowledgeable, surrounded by abundance. Their culture was sophisticated, Their future was unfolding. And then, in a span of time shorter than a human lifetime, almost all of it was gone. The mammoths, the mastodons, the giant sloths and saber-toothed cats and dire wolves, and short-faced bears and camels and horses. 35 genera of large mammals in North America went extinct at the end of the Pleistocene. 35 entire groups of animals, each containing multiple species, wiped out. In South America, the number was even higher. 50 genera lost. This was not a gradual process. This was not slow climate change giving animals time to adapt or migrate. The fossil record shows a sharp cutoff. Before the Younger Dryas boundary layer, these animals are everywhere. After it, they are gone. And the Clovis culture, the archaeological signature of these people who had been so successful, it changes abruptly too. When human activity picks up again, it is different. The tools are different. The methods are different. Something broke, not just the ecosystem, not just the climate, but the cultural continuity, the accumulated knowledge, the carefully maintained balance between people and the land they lived on. Population genetics studies of modern Native Americans show evidence of a bottleneck around this time, a dramatic reduction in population, visible in the DNA of everyone alive today who descends from the people who were here then. Somewhere between 60 and 70% of the human population in the Americas may have died. Imagine that. Imagine 2 out of every 3 people you know just gone. But here is what I want you to hold on to. Here is what matters. Not everyone died. Some people made it through. Enough people made it through that the story continued, that genes were passed on, that knowledge, even if changed, even if diminished, survived. Your existence, if you have any Native American ancestry, is direct proof that someone, somewhere, refused to give up. And even if you do not have that ancestry, you descend from people who survived other catastrophes, other bottlenecks, other moments when it seemed like the story might end. Every single human alive today is the descendant of survivors. We come from the ones who held on when holding on seemed impossible, who found food when there was almost none, who kept their children alive through the coldest, darkest, most terrifying years imaginable. That is in you. And it all started here, in a world we lost, but that lives on in the bones beneath our feet and the blood in our veins. So how do we know any of this actually happened? That is the question, right? Because 12,800 years is a very long time. There are no written records, no photographs, no eyewitness accounts we can read, just rocks and bones and layers of dirt that scientists have to interpret like detectives arriving at a crime scene thousands of years too late. And for a long time, honestly, we did not know. We knew the climate changed rapidly. We knew all these animals went extinct. But the why remained a mystery, wrapped in geological layers and academic debates. The story of how we figured it out is almost as fascinating as the catastrophe itself. It starts, like many scientific discoveries, with someone noticing something that does not quite fit. In the late 1990s, a nuclear physicist named Richard Firestone was working at Lawrence Berkeley National Laboratory. His main research had nothing to do with ancient catastrophes, but he had a side interest in archaeology. And he started collaborating with archaeologists who were studying Clovis sites across North America. They kept finding this weird layer in the soil, right at the boundary between the Pleistocene epoch and the Holocene, right at the point where Clovis artifacts suddenly stop appearing. There was this thin black mat, sometimes just a few centimeters thick, dense, charred. At first, they thought maybe it was just evidence of wildfires. North America has always had wildfires. Lightning strikes, dry conditions, fires sweep through grasslands and forests. Natural part of the ecosystem. But this layer was everywhere. Not just in one region. Not just in areas prone to fires. It showed up in places that should not have all burned at the same time. And when Firestone started analyzing the material more carefully, using the sophisticated equipment available at the lab, he found things that made no sense in the context of ordinary wildfires. He found nanodiamonds. Now, diamonds form under intense pressure and heat, deep in the earth. The tiny diamonds he was finding, so small you need an electron microscope to see them. They were a specific type called Lonsdaleite, hexagonal diamonds. And here is the important part. Lonsdaleite only forms under incredibly specific conditions. Extreme pressure and heat happening very, very quickly. The kind of conditions you get from two things: nuclear explosions or cosmic impacts. Since nobody was detonating nuclear weapons in North America 12,800 years ago, that left one option. He found something else too. Magnetic spherules, tiny little beads of rock that had been melted, turned liquid, then cooled back into solid form while spinning through the air. That is why they are spherical. They were droplets of molten rock, flying through the atmosphere, surface tension pulling them into perfect little spheres before they hardened and fell back to Earth. You do not get those from forest fires. You get those from something hitting the ground hard enough and hot enough to vaporize rock. Firestone brought in other researchers: geologists, geochemists, archaeologists. In 2006, they presented their findings at a scientific conference. The hypothesis was bold. Fragments of a comet had struck North America at the start of the Younger Dryas period. The scientific community did not exactly embrace this idea immediately, and I want to be honest with you about that. Because science is not about one person making a dramatic discovery and everyone instantly agreeing. Science is messy. Science is people arguing about evidence, designing new tests, looking for flaws in each other's reasoning. That is how it is supposed to work. Some scientists looked at the evidence and said, yes, this makes sense. Others said, no, we are not convinced. We need more data. Some proposed alternative explanations. Maybe those nanodiamonds came from volcanic eruptions. Maybe the spherules were from something else. Maybe the carbon layer was just a lot of small fires happening around the same time by coincidence. The debate got heated. Papers were published. Counterpapers were published. Careers got invested in being right. But here is what happened over the next 15 years. More evidence kept showing up. Other research teams, working independently, started finding the same black mat layer at sites all over the world. Not just North America, Europe, Syria, South America, eventually more than 50 sites across 4 continents, all showing the same signature at the same point in time. They found platinum. Concentrations up to 100 times higher than normal background levels. Platinum is rare in Earth's crust, but common in asteroids and comets. Finding a spike of it at the Younger Dryas boundary, that is significant. They found iridium, another element rare on Earth but common in space rocks. The same kind of iridium spike that helped scientists figure out an asteroid killed the dinosaurs 66 million years ago. They found shocked quartz, mineral grains that show a specific microscopic structure that only forms when quartz is subjected to the kind of pressure wave you get from high-velocity impacts or nuclear blasts. They found high-temperature melt glass, rock that had been heated to over 2,000 degrees Celsius and then cooled rapidly. They found soot, massive amounts of it. Chemical analysis showed it came from burning biomass, plants and trees, across enormous areas. One estimate suggested 10% of Earth's total biomass burned in a very short period of time. And they found all of this in a layer that could be dated, using multiple independent methods, to 12,800 years ago, give or take a century. Layer after layer of evidence, all pointing to the same conclusion. Something from space hit Earth. Hard, multiple times. And it triggered a cascade of catastrophes that changed the planet. But skeptics had a fair question. If something hit us that hard, where are the craters? Impact craters are big. They are obvious. The Chicxulub crater from the dinosaur-killing asteroid is over 100 miles wide. You can see it from space, even though it is mostly buried under the Yucatan Peninsula. If a comet hit North America 12,800 years ago, where is the smoking gun? Where is the giant hole in the ground? For years, that was the weakness in the hypothesis. Until 2018, a team of scientists working in Greenland, using ice-penetrating radar to map the bedrock beneath the ice sheet, found something unusual: a circular depression, perfectly round, with raised rims and a central peak. The characteristic shape of an impact crater. They named it Hiawatha, after the glacier that sits above it. Hiawatha crater is 19 miles wide. Not as big as Chicxulub, but still massive. big enough that the object that created it would have been over a mile across. The ice above it is 3,000 feet thick, which is why nobody found it until we had the technology to see through ice. Dating the crater precisely is difficult because it is buried under all that ice, but the initial estimates put it right in the range of the younger Dryas boundary. And here is the thing. Hiawatha probably was not the only impact. The hypothesis is not that one big object hit Greenland. The hypothesis is that a comet, much larger, broke apart as it entered Earth's atmosphere. Maybe it broke apart earlier, out in space, and Earth passed through a debris field. Either way, multiple fragments came down. Some hit ice, some hit land, some probably hit the ocean, where they would leave no crater we could find, because the ocean floor recycles itself over millions of years through plate tectonics. The largest fragments would have created impacts. Smaller fragments would have exploded in the atmosphere, airbursts that did not leave craters but still released enormous energy. Think of the Tunguska event in Siberia in 1908. A fragment of comet or asteroid exploded in the air over a remote forest, flattening 80 million trees across 800 square miles. No crater, just devastation. Now imagine dozens of Tunguska-level airbursts happening across the northern hemisphere in the span of a few hours or days. That is what the evidence suggests, and the effects would have been immediate and catastrophic. The airbursts and impacts would have generated thermal radiation intense enough to ignite forests across thousands of square miles. Animals caught in the open would have been killed instantly by the heat or the pressure waves. The ones that survived the initial blasts would have faced a landscape on fire. Ice sheets 2 miles thick would have been punctured. Massive amounts of ice would have been vaporized or thrown into the atmosphere. The meltwater would have poured into the oceans, into rivers, creating floods of biblical proportions. All that debris, all that vaporized rock and ice and burning material, and then the temperature would have started to drop. We can see this in the ice cores from Greenland. Scientists drill down through thousands of feet of ice, extracting cylindrical cores that preserve a record of snowfall going back hundreds of thousands of years. Each layer of ice traps tiny bubbles of ancient atmosphere. By analyzing those bubbles, we can measure what the temperature was, what the atmospheric composition was, year by year. And at the 12,800 year mark, the ice cores show a sharp, dramatic shift. Oxygen isotope ratios change in a way that indicates sudden cooling. Within a decade, maybe less, temperatures in the northern hemisphere dropped by 15 degrees Fahrenheit. 15 degrees does not sound like much, maybe. It is the difference between a climate that can support forests and grasslands and one that cannot, and it happened fast. Not over generations, not over centuries, fast enough that trees could not adapt, fast enough that animals could not migrate to warmer areas, fast enough that human populations, even with all their skill and knowledge, were overwhelmed. The Younger Dryas period lasted 1,200 years. 1,200 years of cold, of ice sheets growing again instead of retreating, of shortened growing seasons and disrupted ecosystems and megafauna dying off because their food sources disappeared. And at the end of those 1,200 years, when the climate finally warmed again and stabilized, the world that emerged was fundamentally different from the one that existed before. Now, I need to tell you something important. Not every scientist accepts this hypothesis. Even today, even with all this evidence, there are researchers who remain skeptical. Some argue the nanodiamonds could have other sources. Some think the platinum spike is not as significant as it seems. Some believe the megafauna extinctions were caused by human overhunting or climate change unrelated to an impact. This is normal. This is how science works. A hypothesis is never proven beyond all doubt. It is just supported by more and more evidence until it becomes the best explanation we have for the observations. The Younger Dryas impact hypothesis is not universally accepted yet, but it is gaining support. More research teams are finding corroborating evidence. More sites are being discovered with the same signature. The Hiawatha crater was a major breakthrough. If other craters are found, and teams are actively looking in places like the Great Lakes region and other areas that would have been covered by ice sheets, the case becomes even stronger. But here is what I find beautiful about this. the uncertainty, the ongoing investigation, the fact that we are still piecing this together, because it means the story is not finished. Somewhere out there, right now, there is a graduate student examining soil samples who might find the next crucial piece of evidence. There is a team planning the next expedition to drill into ice or survey lake beds or excavate a new site. There are people dedicating their careers to understanding what happened to our planet 12,800 years ago. They are doing this because they care. Because they want to know the truth. Because understanding our past helps us understand ourselves. And in a weird way, that connects us to the people who lived through the catastrophe. They survived because they paid attention, because they learned, because they adapted to new information about their environment. We are doing the same thing, just with different tools. We are reading the scars the impact left in the earth. We are learning what happened. We are honoring the people who made it through by refusing to forget. And if you are finding this fascinating, if your mind is lighting up with questions and connections, maybe hit the like button. It helps other people discover these stories, and if you want to support this kind of deep dive storytelling, channel membership is a simple way to do that. No pressure. Either way, I am just glad you are here, listening, wondering about this with me, because that curiosity, that desire to understand, that is part of what makes us human too. It is part of what kept our ancestors alive when everything was falling apart. They did not give up trying to make sense of their world. They kept observing, kept learning, kept passing knowledge to the next generation. And we are still doing it. Still asking questions. Still looking for answers. Still telling the story of where we came from and what we survived to get here. The evidence is all around us. Written in rocks, frozen in ice, buried in layers of earth that remember everything. We just have to know how to read it. Let me try to help you imagine something that is almost unimaginable. It is a night like any other night, 12,800 years ago, somewhere in what we now call Montana or Michigan or Pennsylvania. The exact location does not matter. What matters is that people are settling in for the evening. Fires are being tended. Children are falling asleep wrapped in furs. Adults are talking quietly, making plans for tomorrow's hunt, repairing tools, telling stories. The stars are out, brilliant and countless. And then, without warning, one of those stars starts moving. At first, it is just a bright point, growing larger. Someone notices, points. Others look up. The moving star gets brighter and brighter. It is not a star at all. It is something falling toward them from the depths of space. Something that has been traveling through the cold and dark for millions of years. And tonight, by pure chance, its path intersects with Earth. The object is huge. Estimates suggest the original comet nucleus might have been several miles across. But by the time it reaches Earth's atmosphere, it has already begun to break apart. The stress of entering the atmosphere at maybe 40 or 50 miles per second, the friction, the heat, it is tearing the comet into fragments. And those fragments are spreading out, each one following a slightly different trajectory, each one about to hit a different part of the northern hemisphere. The first fragment hits the Laurentide ice sheet, the massive glacier covering most of Canada and the northern United States. Imagine a chunk of rock and ice, maybe a mile wide, slamming into a glacier at tens of thousands of miles per hour. The energy released is beyond anything in human experience. One estimate puts it at millions of megatons. For comparison, the largest nuclear weapon ever tested, the Tsar bomber, was 50 megatons. The fragment does not just hit the ice, it punches through it. 2 miles of ice, vaporized or thrown into the air in an instant. The bedrock beneath is exposed, melted, shocked by pressure waves that turn solid rock into something that behaves briefly like a liquid. A crater forms, 19 miles wide, the Hiawatha crater that scientists would not discover until 12,800 years later, buried under new ice that slowly accumulated over the millennia. But the crater is not the only effect. Not even close. The impact releases a thermal pulse. Imagine the brightness, the heat. For hundreds of miles in every direction, anything combustible ignites. Trees burst into flame. Grass, dried by the end of summer, catches fire, and the flames race across the landscape faster than any animal can run. The shockwave follows. a wall of compressed air moving faster than the speed of sound. It flattens forests. It kills anything in the open, not from the pressure itself, but from being thrown, tumbled, smashed against rocks and trees and the ground. And then there is the ejector. Billions of tons of ice and rock, vaporized or melted, or simply thrown upward by the force of the impact. Some of this material goes straight up into the stratosphere, where it will stay for months, spreading around the globe, blocking sunlight. Some of it follows ballistic trajectories, falling back to Earth hundreds or thousands of miles away, still glowing hot, starting new fires wherever it lands. But this is just one fragment, just one impact, because while this is happening in Greenland or northern Canada, other fragments are hitting other locations. One might have come down over the Great Lakes region, another over the Atlantic Ocean, maybe one over what is now the northern United States. The evidence suggests multiple impacts, spread across the northern hemisphere, happening within hours or days of each other, and some fragments do not even make it to the ground. They explode in the atmosphere, airbursts that release their energy at altitude. These might be even more devastating than ground impacts in some ways. The thermal radiation spreads over a wider area. The pressure wave hits the ground with tremendous force, but does not create a crater, just flattens everything for hundreds of square miles. Think about the Tunguska event again. 1908. Siberia. An object maybe 200 feet across explodes about 5 miles up. The forest below is destroyed across 800 square miles. Trees are knocked down in a radial pattern, all pointing away from the center of the blast. And this was a relatively small object. Now, multiply that. Dozens of airbursts. Some from fragments much larger than the Tunguska object. All across North America. All within a very short period of time. The sky would have been lit up like daylight. Multiple suns appearing, blazing, some of them exploding in mid-air with flashes brighter than anything the sun ever produces. The sound would have been beyond deafening, thunder that shakes the ground, sonic booms that rupture eardrums, the roar of fires spreading everywhere at once. And the fires, we need to talk about the fires. The evidence shows that approximately 10% of Earth's biomass burned. Forests, grasslands, peat bogs, everything that could burn, burning simultaneously across huge swaths of the northern hemisphere. The smoke would have been visible from space if anyone had been up there to see it. Plumes rising thousands of feet into the atmosphere, merging into a pall of darkness that spread with the wind. Ash falling like snow, the smell of burning everywhere. The air thick and hard to breathe. Animals would have run, those that could run. Mammoths and mastodons fleeing the flames, trying to find water, trying to outpace the fire. Many of them did not make it. Some kill sites show evidence of animals dying en masse, groups of them together, perhaps trapped by the spreading flames or overcome by smoke. And the people? The families we imagined at the beginning, what did they experience? If they were close to an impact site, they died instantly. There is no surviving a direct hit, or even being within 100 miles of one. The heat, the shockwave, the flying debris, death would have been instantaneous, but most people were not that close. Most people were somewhere else, far enough away that the impact did not kill them immediately, but not far enough to escape the consequences. They would have seen the sky light up, heard the sound rolling across the landscape like continuous thunder. They would have seen the fires on the horizon, watched the smoke blot out the stars, and they would have had no idea what was happening, no framework to understand it. In their entire history, in all the stories passed down through generations, nothing like this had ever occurred. This was outside the realm of human experience. Some of them probably thought the world was ending. And in a way, they were right. The immediate effects killed millions of animals and probably hundreds of thousands of people. But the immediate effects were just the beginning. All that debris thrown into the atmosphere, all that smoke and ash and vaporized material, it did not just disappear. It spread. It formed a layer in the stratosphere, reflecting sunlight back into space before it could reach the ground. This is the same effect you get from a massive volcanic eruption. Mount Tambora, in 1815, ejected so much material into the atmosphere that the following year, 1816, was called the year without a summer. People starved. And that was from one volcano. The younger Dryas impact put far more material into the atmosphere than Tambora. Within months, maybe weeks, the temperature started to drop. The sun, when you could see it through the haze, looked dim and reddish. Days were darker, nights were colder, and then the feedback loops kicked in. Snow that fell did not melt. It accumulated. White snow reflects sunlight, which cools things further, which means more snow, which reflects more light. The ice sheets that had been retreating, melting back toward the poles as the climate warmed, they stopped retreating. They started advancing again. In the oceans, something even more dramatic happened. The massive amounts of fresh water from melted ice, flooding into the North Atlantic, disrupted the ocean currents, specifically the Atlantic Meridional Overturning Circulation, the current system that brings warm water from the tropics northward and cold water southward. When you dump millions of cubic kilometers of fresh water into the North Atlantic in a short period, it changes the salinity. Fresh water is less dense than salt water. It does not sink the way cold, salty water normally does. And if the cold water does not sink, the warm water from the south does not flow in to replace it. The current shuts down. This is catastrophic for Northern Hemisphere climate. The Gulf Stream, part of this circulation system, is what keeps Europe and the North Atlantic region much warmer than they would otherwise be at that latitude. London is as far north as Calgary, but London does not have Calgary's winters. That is because of the Gulf Stream bringing warm water from the Caribbean. When the circulation shut down at the start of the Younger Dryas, that warmth stopped flowing north. Europe froze. The North Atlantic region froze. Ice cores show the temperature drop happened in less than a decade. Some estimates suggest it might have happened in as little as 3 years. 3 years from temperate climate to ice age conditions. Imagine living through that. The summers getting shorter and cooler each year. The winters getting longer and harsher. Snow falling earlier in the fall, lingering later into spring. And then one year the snow just does not melt at all. The plants that people relied on for food, they could not survive these conditions. Growing seasons shortened to the point where many plants could not complete their life cycles. Forests began to die. Grasslands turned to tundra. And the megafauna, those enormous animals that had thrived in the rich ecosystems of the late Pleistocene, they started to starve. Mammoths and mastodons needed hundreds of pounds of vegetation every day. When the vegetation disappeared, when forests died and grasslands failed, these animals had nowhere to go. They could not migrate fast enough. The climate change was happening too quickly, and many of them were already weakened or injured from surviving the initial impact and fires. Within a few centuries, most of them were gone. Not all at once. Not in one dramatic extinction event, but steadily, population by population, as the available food dwindled and the cold intensified and the ecosystems they depended on collapsed. Some species held on longer than others. Mammoths survived on isolated islands in the Arctic until just 4,000 years ago, but on the mainland, they were gone within 1,000 years of the impact. And humans were starving too. The archaeological record shows a dramatic decline in human activity at the start of the Younger Dryas. Fewer sites, simpler tools, evidence of dietary stress in the bones we have found. People were eating anything they could find, shifting from specialized big game hunting to a more generalized diet, fishing more, gathering shellfish, eating smaller animals. Population dropped. Communities fragmented. Knowledge was lost. Skills that took generations to develop, they died with the people who knew them because there was not enough stability to pass them on. It was a dark age. A real one. More than 1,000 years where human civilization, such as it was, regressed. Where survival was the only goal and everything else was a luxury no one could afford. But here is the thing I want you to understand. Here is the part that matters. The part that I think about when the world feels overwhelming. Not everyone died. Some people made it through. They made it through by being resourceful, by adapting, by helping each other. Families stayed together. Communities, the ones that survived, they shared what little they had. Grandparents taught grandchildren everything they knew. everything that might help them survive one more winter. And slowly, so slowly, the world began to heal. The debris in the atmosphere, it eventually settled out. The ocean currents, disrupted but not destroyed, gradually re-established themselves. The ice sheets reached their maximum extent, and then, finally, began to retreat again. By 11,600 years ago, the younger Dryas was over. Temperatures rose. The climate stabilized into the relatively warm, stable Holocene epoch that we still live in today. And the humans who survived, they did not just go back to the old ways. They could not. The old world was gone. The megafauna were mostly extinct. The Clovis culture was over. But they built something new. Something that would, eventually, lead to agriculture, to permanent settlements, to civilization. That is a story for the next part. But right now, I just want you to sit with this for a moment. The scale of it, the violence and the beauty and the terrible randomness of a comet fragment hitting our planet at just the wrong moment in time, and the fact that we are here at all, that enough people survived, that they were strong enough and stubborn enough and hopeful enough to keep going, to have children, to pass on their stories, to ensure that the chain of humanity did not break. You are descended from those people, whether your ancestors were in North America or Europe or Asia or anywhere else. They lived through climate catastrophes and disasters, and moments when it seemed like everything was ending, and they survived. They survived so that you could be here, right now, listening to this story, safe and warm, allowed to rest. Hold on to that. We will come back to it, but for now, just breathe. You are okay. The catastrophe was 12,800 years ago. It is over. We made it through. And if you would like to support this kind of storytelling, channel membership is a simple way to do that. It helps me keep making these long-form documentaries, these nighttime companions for people who want to learn and rest at the same time, but only if it feels right. Either way, thank you for being here. Now let us talk about what happened next, about the survivors, about what it took to rebuild a world from ashes and ice. This is the part that gets me, not the disaster itself, as terrible as it was, but the morning after, and the morning after that, and all the mornings that followed for the next 1,200 years. Because the comet fragments eventually stopped falling, the fires eventually burned themselves out, the shockwaves faded. The initial catastrophe, as devastating as it was, it ended. But the people who survived it, they had to keep living. And that, in some ways, was harder. Picture a family. Let us say they were lucky enough to be far from any direct impact. Maybe they were in what is now the southwestern United States, or Central America, somewhere the immediate effects were less severe. They saw the sky light up. They felt the ground shake. They watched smoke rise on the horizon. But they survived the first night. The next morning, they wake up to a world that looks almost normal. The sun rises, though maybe it seems a little dimmer through the haze. The air smells like smoke, but the fires are far away. They are alive. Their children are alive. But over the next weeks and months, they start to notice things changing. The temperature drops. Not all at once, but steadily. Each day, a little colder than it should be. Summer does not feel like summer. The plants they know, the ones they rely on for food, they are not growing the way they should. Some of them are not growing at all. The animals are acting strangely, migrating at the wrong times, disappearing from areas where they have always been abundant. The great herds of mammoths and mastodons that used to pass through seasonally, they do not come, or when they do come, there are fewer of them. Desperate. And the people themselves, they are hungry, constantly hungry. The food they stored for winter runs out faster than expected because winter lasts longer. Spring comes late. The growing season is too short. Things that used to be reliable are not reliable anymore. This is not a story with dramatic moments. This is a story of slow, grinding pressure, of making do with less, of watching your children go to bed hungry and knowing there is nothing more you can give them. The archaeological evidence paints this picture very clearly, if you know how to read it. Clovis sites, those places where we find the beautiful, carefully crafted spear points, that were the signature of a successful culture, they stop appearing right at the Younger Dryas boundary. The technology does not gradually evolve into something else. It just ends. What replaces it is different, simpler in some ways. The Folsom culture that emerges uses smaller points, lighter projectiles designed for hunting smaller game. Because the big game is mostly gone, mammoths and mastodons, the animals that Clovis people had specialized in hunting, they are disappearing. At some sites, we find evidence that people were eating things they had not eaten before. Shellfish, small mammals, birds, seeds, and nuts that require a lot of processing for relatively little nutrition. This is not the diet of people living in abundance. This is the diet of people eating whatever they can find. The human population dropped dramatically. Genetic studies of modern Native Americans show a clear bottleneck in the DNA record around this time. A bottleneck means that the population shrank so much that only a small fraction of the genetic diversity that existed before made it through to the other side. Estimates suggest that 60 to 70% of the human population in the Americas died during the Younger Dryas period. Some from the immediate effects of the impact, many more from starvation, from exposure, from the collapse of the ecosystems they depended on. 60 to 70%. Think about what that means. If you knew 10 people before the catastrophe, only 3 or 4 of them made it through. Your neighbors, gone. Your extended family, the cousins and uncles and aunts you gathered with during good times, most of them gone. Entire communities, wiped out not by the fires or the shockwaves, but by the slow, cold, hungry years that followed. And the people who survived, they did not survive because they were the strongest or the smartest, because they had access to resources that others did not, because they made connections with other survivors and pooled what little they had. Luck and cooperation. That is what got humanity through. We see evidence of this in the archaeological record too. During the Younger Dryas, people started living in caves more frequently. Not because they suddenly became more primitive, but because caves offered shelter from the cold. They offered protection from the elements in a way that temporary brush shelters could not provide. Caves are defensible too. In times of scarcity, when resources are limited, there is always the possibility of conflict. Not because people are inherently violent, but because desperation makes people do things they would not normally do. A cave is easier to defend than an open campsite. But alongside the evidence of hardship, we also see evidence of care. Burials continue throughout the Younger Dryas. People are still taking the time to bury their dead with some ceremony, some ritual, even when they are starving, even when every moment is consumed with the struggle to survive. They are honoring the people they lost. That tells us something important. It tells us they were still human, still capable of love and grief, and the belief that some things matter beyond immediate survival. We find evidence of people caring for the injured and the sick, skeletons showing healed fractures, infections that were survived, injuries that would have been fatal without someone taking care of the person while they recovered, feeding them, protecting them, keeping them warm, in a world where resources were scarce, where every mouth to feed was a burden. People still chose to care for each other. Enough that the vulnerable sometimes survived. Enough that compassion did not disappear even when everything else seemed to be falling apart. And they were teaching their children. We know this because the skills survived. Simplified. Yes. Changed. Absolutely. But the knowledge of how to make stone tools, how to process hides, how to make fire, how to find water, how to track animals, all of this was passed down. Imagine being a parent during this time, trying to teach your child the old ways when the old ways do not quite work anymore, trying to explain why the world is the way it is when you do not understand it yourself, trying to give them hope when you are not sure you have any hope left to give, but you do it anyway. Because what else can you do? You tell them the stories your parents told you. You teach them the skills you know. You adapt those skills to the new reality, figuring it out as you go, hoping that what you are passing on will be enough to keep them alive when you are gone. And somehow, impossibly, it worked. The chain did not break. The knowledge did not die. Humanity made it through the bottleneck, diminished and changed, but alive. There is another aspect to this that I find both heartbreaking and beautiful. The loss of cultural knowledge, things that took generations to develop, that represented the accumulated wisdom of thousands of years. They were lost in a single lifetime. The Clovis people had sophisticated knowledge of their environment. They knew migration patterns of animals across thousands of miles. They knew which plants were edible in different regions. They had trade networks that moved high-quality stone from quarries to users hundreds of miles away. Most of that was lost. When the climate changed so rapidly, when the megafauna went extinct, when populations collapsed and communities fragmented, the networks fell apart. The knowledge that depended on those networks disappeared, but some things were preserved. Oral traditions. Stories. The Clovis people did not have writing, but they had language. They had memory. They told stories to make sense of their world, to preserve important information, to maintain their identity as a people. And here is where I start to wonder about something. Pure speculation. Cultures all over the world have flood myths. Stories about a great deluge that destroyed the world. Noah's Ark in the Bible. The Epic of Gilgamesh from ancient Mesopotamia. Hindu texts describing Manu surviving a flood. Greek myths about Deucalion. Aztec legends. Native American stories. More than 150 different cultures have some version of this story. For a long time, scholars assumed these were just metaphors, or exaggerated accounts of local floods, or independent inventions, because floods happen everywhere, and humans like to tell stories about disasters. But what if some of these stories are memories? Deep, distorted, passed down through so many generations that the details have changed, but the core remains. A memory of a time when water came from the sky, when the ice melted catastrophically, when floods wiped out communities, when the world seemed to be ending. The younger Dryas impact would have caused massive flooding. The ice sheet impacts would have melted enormous amounts of ice. That water had to go somewhere. Lake Agassiz, a glacial lake covering parts of what is now Canada, drained catastrophically at least once during the younger Dryas. The amount of water released was equivalent to 10 Amazon rivers flowing at once. Imagine being downstream from that, seeing a wall of water appear on the horizon, taller than trees, moving faster than you can run. Your entire world drowned in minutes. Would you tell your children about it? Would they tell their children? And on down through the generations, the story changing each time, becoming myth, becoming legend, but never quite forgotten. I do not know. We will probably never know, but the possibility that the stories we still tell today might contain echoes of what happened 12,800 years ago, that possibility makes me feel connected to those survivors in a way that facts and figures never could. They were trying to make sense of what happened to them. They were trying to preserve some memory of it. They were doing what humans have always done when faced with catastrophe. They were telling stories, and we are still telling those stories. This documentary is a story. The scientific papers about the younger Dryas impact hypothesis are stories. We are still trying to understand what happened, still trying to find meaning in it, still trying to honor the people who lived through it by not forgetting. Because here is what I come back to, again and again. Every single one of us, everyone alive today, we are the descendants of the people who survived the unsurvivable. That family we imagined, hungry and cold, teaching their children how to survive in a world that no longer made sense. They made it. We know they made it because we are here. Their children survived. Their children's children survived, the line continued, unbroken. Through 1,200 years of Ice Age conditions, through starvation and loss and grief, through the extinction of most of the animals they had known and the collapse of the world they understood. And when the climate finally warmed again, when the younger Dryas ended and the Holocene began, their descendants were there, ready to build something new, ready to try again. That is in you. That refusal to give up, that ability to endure when endurance seems impossible, that stubborn, unreasonable hope that things might get better if you just hold on a little longer. You carry the genes of survivors. You carry the legacy of people who faced the literal end of their world and chose to keep going anyway. And I think, in some fundamental way, that is why these stories matter. Not because they teach us facts about the past, though they do. Not because they satisfy our curiosity, though they do that too. They matter because they remind us of what we are capable of, what humans have always been capable of. The strength we have when we thought we had none left. The compassion we show, even when showing compassion, costs us something we can barely afford to give. The hope we maintain, even when hope seems foolish. Your ancestors survived so that you could be here. They went through things we cannot imagine, and they kept the story going. They kept humanity going. You are the proof that it was worth it, that their struggle meant something, that their refusal to surrender, to despair, was justified. And tonight, right now, you get to rest. You just get to be here, safe and warm, listening to a story about people who came before you and made your existence possible. That is a gift. From them to you, across 12,000 years. So breathe. Let your shoulders relax. You are okay. The hard part is over. Not just for tonight, but for this chapter of the human story. We made it through. We are still here, still curious, still telling stories, still looking up at the same stars those survivors saw and wondering what they mean. The catastrophe was real. The suffering was real. But so was the survival. So was the love and the courage and the determination that kept humanity alive when staying alive seemed impossible. And that story continues with you. Here is where the story takes a turn I did not expect when I first started researching this topic, a turn that changes how I think about catastrophe and recovery and what it means to be human. Because the younger Dryas did not just destroy things, it created the conditions for something entirely new. Around 11,600 years ago, the cold period ended. The climate began to warm again, the ice sheets retreated, rivers flowed, forests grew back. The world entered the Holocene epoch, the stable, warm period we still live in today. And within a few centuries of that warming, something happened that had never happened before in all of human history. People started farming, not everywhere at once, not even deliberately at first, but in several regions around the world, independently, humans began the transition from hunting and gathering to agriculture. From following the food to growing the food, from living as nomads to settling in permanent communities. This is the Neolithic Revolution, the birth of civilization as we understand it. And the timing is not a coincidence. The first clear evidence of plant domestication appears in the Fertile Crescent, the region stretching from modern-day Egypt through the Middle East to Iraq and Iran. Around 11,500 years ago, people there began cultivating wheat and barley. They were selecting seeds from the plants with the most desirable traits, saving them, planting them intentionally. Within a few centuries, those plants had changed. The seeds got bigger, the husks got thinner, making the grain easier to process. The stalks became stronger, so they would not shatter and scatter seeds before harvest. These are not natural changes. These are the result of human selection, human agriculture. And right around the same time, also in the Fertile Crescent, at a place called Göbekli Tepe, in what is now southeastern Turkey, people were building monuments, massive stone monuments, T-shaped pillars, some of them weighing over 20 tons, carved from bedrock and transported to a hilltop and erected in circular arrangements. The pillars are decorated with intricate carvings of animals, foxes, snakes, scorpions, birds. The workmanship is extraordinary. This is not crude. This is sophisticated art. And here is the stunning part. Göbekli Tepe was built 11,600 years ago, right at the end of the Younger Dryas, before pottery, before metal tools, before evidence of permanent villages or domesticated animals at that site. These people built temples before they built houses. Think about what that means. They were still living as hunter-gatherers, still moving with the seasons, still relying on wild plants and animals for food, but they were investing enormous amounts of time and energy into creating sacred spaces, places for gathering, places for ritual, places for community. Why? What drove them to do this? The archaeologist Klaus Schmidt, who excavated Göbekli Tepe, had a theory. He suggested that the need to gather regularly at these ritual sites created pressure to stay in one place, and staying in one place created the need for reliable food sources. And that need drove the development of agriculture. In other words, religion came before farming. Belief came before bread. But I think it goes even deeper than that. I think the catastrophe itself shaped this transformation. Imagine you are part of the generation that survived the younger Dryas. Your grandparents told you stories about a world that was warmer, more abundant, filled with animals that no longer exist. Then came the disaster. Then came 1,200 years of cold and scarcity and loss. And now, finally, the world is warming again. But you remember. Your culture remembers. You know that stability is not guaranteed. You know that everything can change, violently and without warning. So what do? You try to control what you can. You do not want to rely entirely on wild plants that might fail, on animal migrations that might not come. You want security, predictability, insurance against the next catastrophe. You start planting seeds, not because you have suddenly become smarter or more advanced, but because you have been traumatized, because you have learned through generations of hardship. And you build monuments, you create gathering places, you develop rituals and beliefs that bind your community together, because you have learned through watching communities fragment and disappear during the hard times that social bonds matter, that coming together, that shared identity, that collective meaning-making. These things help people survive when everything else fails. The catastrophe taught you these lessons. And those lessons changed human behavior in ways that are still shaping our world today. This is not romanticizing suffering. I want to be clear about that. The people who died during the younger Dryas did not die for a reason. Their deaths were not meaningful. They were just tragic, random, the result of being in the wrong place when a comet happened to hit. But the people who survived, they found meaning anyway. They took the trauma and the loss and the knowledge they gained from it, and they built something. They built agriculture. They built permanent settlements. They built social structures complex enough to organize the construction of massive monuments. They built belief systems that helped them make sense of a world that had shown them how fragile everything really is. And over the next few thousand years, this transformed humanity. By 10,000 years ago, farming communities were established across the Fertile Crescent. They were building houses, real houses, with stone foundations and mud brick walls. By 9,000 years ago, settlements were growing into towns. Jericho, one of the oldest continuously inhabited cities in the world, was thriving. Walls were being built, not just around individual houses, but around entire communities. Defense structures, because when you have stored grain and domesticated animals and permanent dwellings, you have something worth defending. By 8,000 years ago, the idea of agriculture had spread to Europe, to East Asia, to Africa, to the Americas. Though there it developed independently, with different crops, corn and beans and squash instead of wheat and barley. And everywhere this happened, the same pattern emerged. Agriculture led to settlements. Settlements led to population growth. Population growth led to specialization. Not everyone needed to be involved in food production anymore. Some people could become craftspeople. Others could become traders. Social hierarchy developed. Written language developed, first as a way to keep track of grain stores and trade goods, but eventually to record laws and stories and history. Civilization, in the form we recognize it, was born, and it all traces back, in some fundamental way, to the reset button that got pressed 12,800 years ago. Now, I am not saying the impact caused civilization. That is too simple. Human beings are inventive and adaptive. We would have figured out agriculture eventually. We would have built communities and cities and complex societies. But the timing matters. The pressure matters. The specific conditions that existed right after the Younger Dryas ended, those conditions accelerated changes that might have taken much longer otherwise. There is something else too, something about diversity and innovation. The younger Dryas bottleneck did not just reduce human population. It scattered survivors, it broke up the large, interconnected groups, and forced people into smaller, more isolated communities just trying to survive. And when the climate improved, when these communities started growing again and making contact with each other, they had developed in different directions, different solutions to the same problems, different technologies, different ideas. When they came back together, that diversity became a resource. Ideas could spread, technologies could be shared and improved. The best solutions from different groups could be combined. Genetic studies show increased mixing of populations after the younger Dryas. People were moving, trading, intermarrying, and with every connection between previously isolated groups, the pool of available knowledge grew. This is how innovation happens. Not from one genius having one brilliant idea, but from many people, trying many things, sharing what works, building on each other's successes. The catastrophe had scattered us. The recovery brought us back together, and we were better for it, stronger, more creative, more capable. I find something profoundly hopeful in this, because it suggests that even our worst moments, even the times when everything seems to be falling apart, can contain the seeds of something better. Not because suffering is good. It is not. Not because we should be grateful for catastrophes. We should not be. But because humans, when pushed to our limits, do not just survive. We adapt. We learn. We create. We find new ways of being that we never would have discovered if everything had stayed comfortable and safe. The people who built Göbekli Tepe, who domesticated the first wheat, who formed the first permanent settlements, they were not trying to invent civilization. They were just trying to make sure their children did not have to go through what they went through. They were trying to create stability in a world that had shown them how unstable it could be. And in doing so, they changed the trajectory of human history. Every city you have ever lived in, every technology you use, every book you have ever read, every piece of music or art or architecture that moves you, all of it traces back through an unbroken chain to those first farmers, those first builders, those first people who decided that they were going to try something new. And they decided to try something new because they had lived through the old world ending, because they knew, in a way we can barely imagine, that nothing lasts forever, that you cannot take anything for granted, that you have to create the security you want to see. We are still doing this. Every time someone plants a garden, they are echoing those first farmers. Every time a community comes together to build something, they are echoing Göbekli Tepe. Every time we try to prepare for the future, to create stability, to leave something better for the next generation, we are carrying forward the lessons learned 12,000 years ago. The catastrophe reset history, but the survivors rewrote it. They took a world that had been burned and frozen and emptied, and they filled it again, with life, with meaning, with hope. That is the real legacy, not the destruction, not the loss, but what came after, what we built from the ashes and the ice, what we became because we refused to let the story end. And you are part of that. You carry that legacy, that creative resilience, that ability to take brokenness and make something whole, that stubborn insistence on moving forward even when you do not know where you are going. Your ancestors survived the unsurvivable, and then they did something even harder. They built a new world, a better world, in many ways, not perfect, but alive, still growing, still changing, still full of possibility. And that story is not finished. It is still being written. Every generation adds their chapter. Every person makes their mark, large or small. Someday, someone will look back at our time the way we look back at the younger Dryas survivors. They will study what we did, how we responded to our challenges, what we built, what we preserved, what we passed on, and I hope they see that we remembered, that we understood we were part of something larger than ourselves, that we knew we stood on the shoulders of people who survived impossible things, and we tried to be worthy of that inheritance. That is what this story is really about. Not ancient history, not distant catastrophes. It is about continuity, about the unbroken chain of humanity, stretching back through time, connecting us to everyone who came before and everyone who will come after. And tonight, right now, you are a link in that chain, resting, listening, remembering. That is enough. Here is what I come back to, again and again. We are living in the aftermath of the Younger Dryas. Right now. Today. Everything around you, the entire shape of human civilization, exists because of what happened 12,800 years ago and how our ancestors responded to it. The Holocene epoch, the period of unusual climate stability that began when the Younger Dryas ended, that is our home. That is the only world any living human has ever known. Stable seasons, predictable rainfall patterns, temperatures that stay within a range that allows agriculture to function. For the last 11,600 years, give or take, Earth has been remarkably kind to us. And in that kindness, we built everything: cities and farms and trade routes and technologies, art and science and philosophy, all of it resting on the foundation of a stable climate. But the Younger Dryas reminds us of something we forget at our peril. This stability is not normal. Not in geological terms. Not in the long history of Earth. For most of the planet's existence, climate has been chaotic. Ice ages lasting hundreds of thousands of years, interrupted by brief warm periods. Rapid swings between extremes. The kind of volatility that makes complex civilization nearly impossible. We got lucky. We got this window of stability. And we used it well. 400 generations. From the end of the Younger Dryas to now. 400 generations of people building on what the previous generation left them, adding their own contributions, passing it forward. That is remarkable. That is worth honouring, but it is also fragile. And I think, deep down, we know this. The same forces that caused the Younger Dryas are still out there. Comets still cross Earth's orbit. The geological record shows multiple impact events throughout history. The dinosaurs 66 million years ago, the Younger Dryas 12,800 years ago, the Tunguska event just over a century ago, which was small by comparison but still flattened 800 square miles of forest. We are not safe from cosmic impacts. We are just lucky that nothing big has hit us recently. Climate tipping points still exist too. The ocean circulation systems that shut down during the Younger Dryas, they are still sensitive to disruption. Scientists today study these systems carefully because we are pumping greenhouse gases into the atmosphere and melting ice sheets and changing ocean salinity. Different mechanism than the Younger Dryas impact, but potentially similar results if we push things too far. The lesson here is not despair. It is perspective. Earth has been through violent changes before. Changes that make our current challenges look small by comparison. A 15-degree temperature drop in a decade. 80% of large mammals going extinct. Human population dropping by 2/3. And we survived. Not just survived, but eventually thrived. That does not mean our current problems are not serious. They are. Climate change, biodiversity loss, all of it matters deeply and deserves our attention and action. But it does mean that humanity is more resilient than we sometimes give ourselves credit for. It means that even when things seem hopeless, even when the systems we depend on are collapsing, people find ways to adapt, to endure, to keep going. The Younger Dryas survivors did not have technology. They did not have agriculture or stored food or global supply chains. They had stone tools and knowledge of their local environment and each other. And it was enough. We have so much more than they did. Not just in terms of technology, but in terms of knowledge. We understand climate systems. We can see changes coming. We can model outcomes and plan responses. We have the ability to cooperate on a global scale in ways our ancestors could not have imagined. If we choose to use these advantages, we can navigate challenges that would have destroyed previous generations. But we have to remember the other lesson too. The one about community and compassion and taking care of each other when resources are scarce. Because the archaeological evidence from the Younger Dryas shows that the communities that survived were the ones that stuck together, that shared what little they had, that made space for the vulnerable instead of abandoning them. In times of crisis, Our first instinct is often to hoard, to protect our own at the expense of others, to see resources as scarce and other people as competition. But that instinct, as natural as it feels, is often counterproductive. The groups that survive catastrophes are the ones that maintain social bonds, that distribute resources even when distribution means everyone gets less, that value cooperation over competition. This is not just ancient history. This is a pattern that repeats throughout human experience. After natural disasters, after wars, after economic collapses, the communities that recover fastest are the ones with strong social ties, where people know their neighbors, where there is trust and reciprocity, and a sense of shared fate. The younger Dryas survivors knew this. They had to know it. Because without cooperation, without community, isolated families would have died alone in the cold. We still need this. Maybe now, more than ever. There is another lesson too, one that is harder to articulate but feels important. It is about meaning, about how humans make sense of suffering. The people who lived through the younger Dryas had no framework for understanding what happened to them. They did not know about comets or climate systems or geological time. All they knew was that their world had ended for reasons they could not comprehend, and they responded by creating meaning, by building temples, by developing rituals and stories and beliefs that helped them process the trauma and move forward. Göbekli Tepe was not built for practical reasons. It did not help anyone find food or stay warm. But it mattered anyway. It gave people a reason to gather, a shared purpose, a sense that even in a world that had shown itself to be random and cruel, there was still something sacred worth preserving. We do this too. We always have. When faced with suffering we cannot prevent or understand, we create meaning around it. We tell stories. We build monuments. We make art. We find ways to transform pain into something that connects us to each other and to something larger than ourselves. This is not weakness. This is not denial. This is how humans survive psychologically, what we cannot change physically. The younger Dryas was not fair. It was not just. It did not happen for a reason or teach people a lesson they needed to learn. It was random, cosmically, terrifyingly random. But the people who survived it created meaning anyway. They took the randomness and the loss, and they wove it into their understanding of the world, into their identity, into the stories they told about who they were and where they came from. And those stories, changed and distorted but never quite forgotten, are still with us, in flood myths, in tales of ancient catastrophes, in the deep human knowledge that the world is not always safe, but that we can survive it anyway. I think about this when the world feels overwhelming, when the news is bad and the problems seem too big, and I start to spiral into anxiety about the future. I think about people 12,800 years ago, watching the sky light up, having no idea what was happening or whether they would survive the night. And then I think about their great-great-great-great-grandchildren, planting the first wheat, building the first temples, taking the broken pieces of the old world and creating something new. The catastrophe did not destroy humanity. It revealed what we are capable of, our resilience, our creativity, our refusal to surrender, to despair, even when despair is the most rational response. And we are still doing this. Every day, in small ways and large ways, adapting to challenges, supporting each other through difficulties, finding meaning in struggle, creating beauty in the midst of chaos. You are doing this too, whether you realize it or not, by doing your work, by being kind when kindness is difficult, by maintaining hope when hope seems foolish. These are not small things. These are the things that keep the human story going. The same things that kept it going through the younger Dryas and every other catastrophe we have faced. The last lesson, the one I hold closest, is this. Time heals. Not in the sense that it erases pain or makes loss acceptable, but in the sense that given enough time, life finds a way to continue, to adapt, to fill empty spaces with new growth. The earth after the younger Dryas was scarred, burned, frozen, but the scars healed. The ice melted. The forests grew back. New species evolved to fill the niches left by extinct ones. The carbon from all those fires eventually became soil that nurtured new growth. Nothing that was lost came back exactly the way it was. That specific configuration of life and landscape and human experience, it is gone forever. But life itself continued. Changed, yes, different, absolutely, but still here, still diverse, still beautiful, still full of possibility, and humanity continued too. Smaller at first, traumatized, diminished, but alive. And from that survival came everything we have now. Every person, every achievement, every moment of joy and discovery and connection. We exist because our ancestors refused to let catastrophe have the last word, because they chose life, even when life was unbearably hard, because they had children and taught them and loved them, and passed on whatever they could of what they knew. That chain has never broken. Not through the younger Dryas, not through any of the countless smaller catastrophes and personal tragedies and moments of despair that every generation faces. It will not break with us either. Whatever challenges we face, individually or collectively, we carry the legacy of people who survived worse, who endured more, who kept going with less. That strength is in you, that resilience, that stubborn, unreasonable, beautiful refusal to give up. You are the proof that catastrophe does not win, that time heals, that life continues, that the story goes on. And tonight, you get to rest in that knowledge. You do not have to be strong right now. You do not have to solve anything or survive anything. You just get to be here, safe, allowed to let go. The catastrophe was 12,800 years ago. It is over. We made it through, and tomorrow, when you wake up, you will carry that legacy forward. Not because you have to, not because anyone is keeping score, but because that is what humans do. We wake up, we keep going, we find reasons to hope even when hope seems impossible. That is enough. That has always been enough. And you know what? I love that we do not have all the answers. I know that sounds strange. We have spent this whole time piecing together what happened, following the evidence, building this picture of a cosmic catastrophe that changed everything. And now I am telling you that there are huge gaps in our knowledge, questions we cannot answer, mysteries that may never be solved. But that is exactly what makes this story alive. What keeps it interesting? What invites you to be part of it? Because the investigation is not over. The story is still unfolding. Right now, as you are listening to this, there are researchers out there looking for answers, drilling ice cores, surveying lake beds, running chemical analyses on soil samples, searching satellite data for circular depressions that might be impact craters we have not found yet. And every few years, someone finds something new. The Hiawatha crater was only discovered in 2018, a 19-mile-wide impact crater, and we did not know it existed until recently because it was hidden under ice. What else is hidden? What else have we not found yet? Scientists are currently investigating another possible crater in Greenland, not far from Hiawatha. Preliminary data suggests it might be even older, but the dating is uncertain, and there are other locations under investigation. Places we cannot easily access with current technology. 75% of Earth's surface is covered by water. If comet fragments hit the ocean, and statistically some of them probably did, those impact sites are incredibly difficult to find. The ocean floor is constantly recycling through plate tectonics. A crater on land can last for millions of years. A crater on the ocean floor might be gone in a few 100,000 years, swallowed by a subduction zone or buried under sediment, so we may never find all the impact sites. We may never know exactly how many fragments hit or where they came down or how big they were, and honestly, that is okay. We do not need to know everything to understand what happened. The evidence we have is sufficient to reconstruct the broad picture. Multiple impacts or airbursts, massive energy release, fires and climate disruption and extinction. The details matter for scientific precision, but the human story remains the same regardless of whether there were 3 impacts or 10. What I find myself wondering about more is the human side of things. The parts that cannot be preserved in geological layers or ice cores? Did anyone see it coming? Were there warning signs in the days or weeks before? A meteor shower, perhaps, as Earth approached the debris field? Bright streaks in the night sky getting more frequent, more intense? If there were, what did people make of them? Did they feel a sense of foreboding? Did they tell each other stories about what the lights in the sky might mean? Or did they just think it was beautiful, having no idea what was about to happen? And during the impact itself, during those hours of fire and chaos and destruction, what did people do? We know some survived, but how? Did they run to water? Did they shelter in caves? Did families stay together or get separated in the confusion? Were there acts of extraordinary courage? Parents sacrificing themselves to save their children? Communities working together to rescue the vulnerable? Or was it every family for themselves, raw survival instinct overriding everything else? We will never know. These moments, these individual human experiences, they are lost to time. No written records, no oral traditions specific enough to capture the details, just the aftermath, preserved in bone and stone. But I cannot help but wonder. And then there is the question of memory, of whether the catastrophe left traces in human culture beyond the genetic bottleneck and the technological changes. Those flood myths I mentioned earlier, the ones that appear in cultures all over the world, are they memories? Distorted, certainly. Passed through so many generations that the details have become fantastical. Some of the flood myths include details that are eerily specific. Waters coming from above and below, the world covered in darkness, a remnant of humanity surviving to repopulate the earth. These elements appear again and again in cultures that had no contact with each other. Coincidence? Universal human metaphor for disaster and renewal? Or deep cultural memory, preserved in story form because story is how pre-literate societies keep knowledge alive? We cannot prove it either way. And that bothers some scientists, this uncertainty. But I think it is beautiful. The possibility that when we tell these ancient stories, we might be repeating words that have been passed down through 400 generations. That somewhere in the Epic of Gilgamesh or the story of Noah or the Native American flood legends, there might be a grain of truth about what our ancestors witnessed. It connects us to them in a way that facts alone cannot. There are other mysteries too. Smaller ones, perhaps, but still intriguing. Why did some animals survive when others went extinct? The mammoth and mastodon died out, but bison made it through. Saber-toothed cats disappeared, but mountain lions survived. What made the difference? Was it diet, geographic range, reproductive strategy? Scientists have theories, but no definitive answers. The extinction pattern does not fit neatly into any single explanation. It was probably a combination of factors, different for each species, complicated by the fact that ecosystems are interconnected in ways we still do not fully understand. And here is something that really gets me. We know the climate warmed again at the end of the Younger Dryas. We know the ice sheets retreated and the Holocene began. But we do not know exactly why. The leading theory is that it was just the natural progression of Earth's climate cycles, the factors that caused the ice ages, the slight wobbles in Earth's orbit that change how much sunlight different parts of the planet receive. They were already pushing us toward a warmer period. The Younger Dryas was a disruption, a temporary reversal, but eventually the underlying trend reasserted itself. But what triggered the end? What tipped the climate back toward warming after 1,200 years of cold? Was it gradual or sudden? The ice cores show the warming was relatively rapid, geologically speaking, over a few decades rather than millennia. But what caused that acceleration? We have hypotheses, we have models, we do not have certainty. And maybe we never will. Climate is complicated. The further back in time you go, the less data you have, the more you have to infer from indirect evidence. There are limits to what we can reconstruct. But those limits, they do not make the story less true. They just make it more honest, more humble, more open to revision as new evidence emerges. Science is not about having all the answers. It is about asking good questions and being willing to change your mind when the evidence suggests you should. The Younger Dryas impact hypothesis itself is still debated, still being tested. still controversial in some circles. And that is how it should be. Extraordinary claims require extraordinary evidence. The burden of proof is on the people proposing the impact, and they are meeting that burden slowly but steadily as more data accumulates. But even if the hypothesis is eventually proven beyond doubt, even if we find a dozen impact craters and everyone agrees this is what happened, there will still be mysteries, still questions we cannot answer, still aspects of the story that remain forever unknowable. The exact number of people who died, the names of any of them, what they thought about as they watched their world change, what stories they told their children to help them make sense of it, how they mourned, how they hoped, how they found the strength to keep going. These things are gone. Not just unknown, but unknowable. Lost to the passage of time in a way that no amount of scientific advancement can recover. And I think that is okay. I think it is even necessary, because it reminds us that the people we are studying were not just data points, not just populations and genetic markers and tool traditions. They were individuals, with inner lives as rich and complex as ours, with thoughts and feelings and experiences that mattered to them even though we will never know what they were. Honoring that unknowability is a way of honoring their humanity, of acknowledging that they were more than the traces they left behind. Every question we cannot answer is just another invitation. An invitation to imagine, to wonder, to feel connected across the vast gulf of time to people who were fundamentally like us, facing challenges we can barely comprehend, doing their best with what they had. Maybe someday, someone listening to this will be part of finding new answers. Maybe you will be the graduate student who discovers another impact crater, or the geneticist who uncovers new information about population movements, or the archaeologist who finds a site that changes how we understand human behavior during the younger Dryas. Or maybe you will just be someone who tells this story to someone else, who keeps the memory alive, who passes on the wonder and the respect and the deep appreciation for how hard our ancestors fought to give us this world. That matters too, maybe more than we realize, because the real mystery, the one that underlies all the others, is not about what happened 12,800 years ago. It is about what it means that we are here at all, what it means to be part of this unbroken chain of survival and adaptation and stubborn hope stretching back through time. And that mystery, I do not think we will ever fully solve. But we can live into it. We can honor it. We can let it shape how we move through the world and how we treat each other and how we think about our place in the long story of humanity. The questions that remain unanswered, they are not failures of knowledge. They are openings, spaces for wonder, invitations to keep looking, keep asking, keep caring about where we came from and what it took to get us here. And that feels right. That feels true. That feels like exactly the kind of legacy those survivors would want us to carry forward. Not certainty, not complete knowledge, but curiosity, humility, respect, and the willingness to live with mystery while still searching for understanding. The earth healed. It always does. Slowly, patiently, after the fires burned out, after the debris settled from the atmosphere, after the coldest years of the younger Dryas began to soften, the planet started the long work of recovery. It did not happen all at once. It was not dramatic. There was no single moment when everything suddenly got better. It was gradual. Season after season, year after year. The first spring after the impact, maybe nothing grew. The ash was too thick, the soil too disturbed, the temperature too cold. But the second spring, a few seeds germinated. Plants that had survived in sheltered places, their roots deep enough to escape the worst of the fires. They pushed up through the ash, thin green shoots reaching toward a sun that was still dimmed by haze. And those plants made seeds. And some of those seeds survived the next winter. And the cycle continued. Grass is stubborn. It burns and comes back. It freezes and comes back. Give it any chance at all, and it will take it. So the grasslands returned. Not the same grasslands, different species in different proportions, but green nonetheless. Living, the forests took longer. Trees grow slowly, and the cold of the younger Dryas killed many species that could not adapt quickly enough. And when the climate finally warmed again, their descendants spread, oak and pine and birch, moving north again as the ice retreated, slowly reclaiming ground that had been frozen for over 1,000 years. Rivers that had been choked with ash and debris, they ran clear again. Season after season of rainfall, carrying away the evidence of catastrophe, burying it under new soil, new growth, new life. And animals returned, not the same animals. The mammoths were gone, the mastodons were gone, but other species expanded into the empty niches. Bison, elk, deer, smaller and more adaptable than the megafauna they replaced, but alive, thriving in their own way. Birds nested in the trees that grew back. Their eggs hatched. Generations of birds, each one unaware of the catastrophe that had come before, just living and singing and building nests in a world that had almost ended. Insects pollinated flowers. Fish returned to rivers that had been too warm or too cold, but were now just right again. Predators followed prey. Ecosystems rebuilt themselves, piece by piece, connection by connection, until the web of life was whole again. This is what Earth does. This is what life does. Given time, given even the smallest opening, life finds a way back. The scars remained, of course. The black mat layer in the soil, the missing species that would never return, the Hiawatha crater, slowly filling with ice, but never quite erased. But above those scars, new life grew, using the ash as nutrients, using the changed landscape as an opportunity. 1,200 years. That is how long the younger Dryas lasted. 1,200 years of cold, of ice expanding instead of retreating, of shortened growing seasons and harsh winters and ecosystems struggling to find balance. For a human lifetime, that seems like forever. For a tree, it is many lifetimes. But for the earth, it is nothing, a moment. A brief interruption in the longer story of recovery and renewal, and then it ended. The climate warmed, the ice melted, the Holocene began, and with that warming came abundance again. Not the same abundance as before the impact. The world had changed too much for that. Rivers swelled with meltwater from the retreating glaciers, wetlands formed, marshes and lakes and streams, creating habitat for fish and birds and all the creatures that depend on water. The growing season lengthened. Plants that could not survive the younger Dryas cold, they spread again. Forests thickened, grasslands expanded, and humans, the survivors and their descendants, they spread too, beginning the experiments with agriculture that would change everything. But that is getting ahead of the story. Right now, I just want you to feel the rhythm of it, the slow, steady pulse of recovery, spring coming a little earlier each year, summer lasting a little longer, the frost arriving a little later in the fall, seeds germinating, roots spreading, leaves unfurling, season after season of growth, each one building on the last, rain falling, softly, steadily, washing everything clean, filling the rivers, feeding the forests, nurturing the grasslands, the sun growing brighter as the atmosphere cleared, the stars becoming visible again at night, the moon rising over a landscape that was healing. Slowly but surely, animals grazing in meadows that had been frozen tundra, birds singing at dawn. The sound of running water, of wind through trees, of life asserting itself against all the reasons it had to give up. And underneath it all, underneath the visible recovery, the soil was changing. The ash from the fires, rich in minerals, was being incorporated into the earth, making it fertile, making it ready for the plants that would come later, for the crops that humans would eventually learn to grow. Death becoming life, destruction becoming the foundation for creation, the old world feeding the new one. This is the pattern. This is what always happens, given enough time. The catastrophe was real. The suffering was real. But so was the healing. So was the recovery. So was the stubborn, patient, inevitable return of life to a world that had been devastated. Time does not erase what happened. The scars remain. The memory remains in layers of rock, but time does allow for healing, for growth, for the creation of something new from the ruins of what was lost. The earth healed. Slowly, patiently, without rushing, without forcing, just season after season of small changes, small improvements, small victories of life over death, of growth over decay, of hope over despair, and eventually, those small changes added up to something beautiful. A world reborn, different from before, but alive, thriving, ready for the next chapter. This is what I want you to remember. Not the catastrophe, not the destruction, but this, the healing, the recovery, the unstoppable, patient, gentle return of life, because it is still happening. Every spring, the world renews itself. Every year, life finds new ways to persist, to adapt, to continue. And you are part of that. Part of the ongoing story of life healing itself, of the world continuing despite everything that tries to end it. So rest now. Let go. Trust the rhythm. Trust the pattern. Trust that time heals, that life continues, that tomorrow the sun will rise and the world will still be here, still growing, still beautiful. You are safe. The catastrophe was long ago. The healing happened. We made it through, and you get to rest in that knowledge. You get to close your eyes and drift, knowing that you are held by the same forces that brought the world back from the edge 12,000 years ago. Life, these things are stronger than any catastrophe, stronger than ice, stronger than fire, stronger than the end of the world, and they are here with you now, gentle, steady, inviting you to let go and rest. You are part of this story. You know that, right? Not just as someone listening, but as someone who carries it forward, who continues the line that never broke, the chain of survival that stretches back through 12,800 years to the night. The sky caught fire and the world changed forever. Every breath you take, you are breathing with lungs that evolved over millions of years, lungs that your ancestors used to survive the younger Dryas, to endure the cold, to keep going when everything seemed impossible. Every beat of your heart is connected to every heart that came before. The grandmother holding her grandchild through the longest winter, the parent teaching their child how to make fire, the teenager learning to hunt in a world where the animals their grandparents knew were already gone. They survived so you could be here, and you do not have to do anything with that. You do not have to earn it or prove yourself worthy or accomplish great things to justify their sacrifice. You just get to be, to exist, to rest, because that is enough. You being here, that is the victory. That is what they were fighting for. Not glory, not monuments, just the continuation, the next generation, the story going on. And tonight, you do not have to carry anything. You do not have to be strong. You do not have to survive anything, or overcome anything, or push through anything. You just get to rest, because you have earned this rest. By being human, by making it through whatever you have made it through to arrive at this moment. Your ancestors would want this for you. They would want you to be safe, to be warm, to have enough, to not have to struggle the way they struggled. They endured so their children would not have to. And their children endured so their children would not have to. On and on, generation after generation, each one hoping the next would have it a little easier. And here you are, the fulfillment of that hope, allowed to lie down in comfort, allowed to close your eyes without fear, allowed to drift into sleep, knowing you are safe. This is what they wanted. So take it. It is yours. You do not have to stay awake. You do not have to keep listening. You do not have to remember any of this. The story will be here tomorrow if you want it. But right now, you can just let go. Let your breathing slow. Let your muscles relax. Let the weight of the day, the weight of everything, just drift away. You are lying down. You are comfortable. You are safe. And that is more than your ancestors had for long stretches of time. That is a gift. a gift from them to you across the vast distance of time. Accept it. Rest in it. The world outside will keep turning. The story will keep unfolding, but you do not have to be part of that right now. You can just be here. Just be still. Just be at peace. The catastrophe was 12,800 years ago. It is over. We made it through. You made it through. And tomorrow, when you wake up, you will carry the story forward without even trying, just by being alive, just by continuing. But tonight, you rest. You let the day end. You let sleep come if it wants to come. And if your mind is still busy, if thoughts are still moving, that is okay too. You do not have to force anything. Just notice them. Let them drift by like clouds, like smoke from an ancient fire, like ash settling after the storm. Everything that needed to happen today has happened. Everything you needed to do, you have done. And anything you did not do, it can wait. Right now is just for you. For rest, for peace, for the deep, quiet knowledge that you are part of something larger than yourself. Something that has survived impossible things and will continue long after you are gone. And that is comforting, not sad, comforting, to know you are part of the chain, that your existence matters, that you do not have to carry everything alone. The story carries you. The pattern holds you. The rhythm of life and time and healing. It continues, whether you are awake to witness it or not, so sleep. If you can, if you want to, if your body is ready, and if you are not ready yet, that is fine too. You are okay. You are safe. The ancestors who survived the unsurvivable, they are with you. Not literally, but in your bones, in your blood, in the stubborn way you keep going even when things are hard. And they would tell you, if they could, that you are doing just fine, that you are enough, that you deserve this rest. So take it. Close your eyes. Let go. The world will still be here in the morning, and so will you. Safe. Rested. Ready for whatever comes next. But that is tomorrow's story. Tonight, you just rest. Good night.